Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over problems 1 to 5 of the Smarter Balanced Assessment Consortium Common Core Test for Grade 11 Math. We're going to be working on problems 1 to 5 of this practice test. Now let's take a look at question number 1. It reads, the graph of y equals x squared is shown on the grid. So this graph right here is y equals x squared. Drag the graph to show the graph of y equals x minus 4 squared plus 2. So if you come across any question on your assessment and you do not know how to respond, there is an I button that gives you a brief tutorial on how to generate the desired response. Okay, so this is just a drag and drop response question. So let's go ahead and answer it. Now, this problem is assessing our ability to generate transformed quadratics, okay? So the equation for a transformed quadratic is y equals ax minus h squared plus k. In this situation, all we need is the vertex. All right? If you have a quadratic in this form, the vertex is simply h for the x coordinate and k for the y coordinate. All right? So this form that we're looking at here, y equals x minus 4 squared plus 2, I'm going to write it underneath this equation right here. Y equals x minus 4 squared plus 2. The coefficient is 1. Now, what is the vertex here? The vertex is h. You see how this 4 lines up with the h. 4 comma k, which is 2. So how do I answer this question? I simply have to drag this graph to a point where the vertex rests on this coordinate point. All right, so just drag it. This is 1, 2, 3, 4 for the x. Move it up 2 units for the y. And there goes your answer. 4, 2, and this is a graph of the equation. Okay, let's move on to question number 2. To advance, you simply click on the next button on the upper right corner of your test page. Okay, so question number 2, it reads, multiply and combine like terms to determine the product of these polynomials. So this problem is assessing our ability to expand or to find the product of polynomials. Okay, so for problem 2, we have two quantities, linear quantities, 2x minus 3 times 5x plus 6. There are different ways you can multiply binomials. You can use the box method. You can multiply vertically, horizontally. You can FOIL out. Whichever method you like, go ahead and use it, but make sure you're careful with your multiplication, okay? So I'm going to do double distribution here, also known as FOIL. So first, 2x times 5x, that's 10x squared. And then outer, 2x times 6, do that again, 2x times 6, 2x times 6 you have plus 2 times 6 is 12x. And then you're going to distribute the negative 3 to these two terms in this quantity. Negative 3 times 5 is negative 15x. And then negative 3 times positive 6 is negative 18. All right, we can combine the like terms, which are the first degree terms in the middle. That yields 10x squared minus 3x minus 18. Okay? Now let's go ahead and enter the results in this answer field right here. Now we're going to type in 10. Now you can type in 10 with your keyboard, or you can just click on the numerical values that correspond to your desired entry. Now, if you want to enter an exponent, there are two ways. You can click on this button right here. Oh, disappeared. Okay, there you go. Or another thing you can do is you can use the caret button, Shift 6 on your keyboard. Okay? Now, if you have a number, it's normally grouped in parentheses, but we want to enter 10x squared. So we just type in x, and I can click on this button or press Shift 6, which is the caret button. Let me do that, Shift 6. You see how it gets exponentiated? That gives me the ability to enter this power here, okay? So 2x squared, press the the right arrow to exit the exponential format, okay? Now we're back to the regular numbers, negative 3x minus 18. All right, so there goes the expanded form with the like terms combined. Let's move on to question number 3. So question 3, it states you are to determine whether each expression is equivalent to x to the third plus 8. Select yes or no for each expression. Now this problem is assessing our ability to factor sum of cubes. Okay, so sum of cubes is what we're going to be looking at here. Now, do you recall the acronym SOAP? SOAP basically helps you remember the pattern of the signs for the factored form of sums and difference of cubes. Okay, so S means same, O means opposite, A means always, positive. So for this mnemonic device, A and P basically go together. Okay, same, opposite, always positive. So that's how the sign changes when you're finding the factored form of a sum or difference of cubes. Okay, so let's go ahead and apply it to the formula. So let's say we have a sum of cubes, a cubed plus b cubed. Okay, the expanded form is going to be a plus b times a squared minus ab plus b squared. Okay, now if you look at it, what do you notice? The first sign is the same as the sign between the two terms that are the two cubes. The next sign is the opposite, so opposite of plus is minus. And the last sign is what? AP, always positive. The same formula or acronym applies to the difference, the factored form for the difference of cubes. Okay, so a minus b, a squared plus ab plus b squared. All right, what do you notice with the sign? The first sign is always the same as the sign between the cubes. The next sign is always the opposite, so the opposite of negative or minus is plus. The last sign is always positive. Okay? So let's go ahead and write that down. So for the first sign, that's same, referring to these two signs right here is always the same as the sign here. The next sign is opposite. And then the last sign, regardless of it, if it's a sum or difference of cubes, is always positive. All right? Okay, now that we have this formula, we can use it to find the factorization of this binomial right here. Okay, this cubic binomial. So we have x to the third plus 8. What kind of number is 8? 8 is a cube. It can be written as x to the third plus 2 to the third. In this case, if we look at our formula, a is going to be x, the cube root of the first term, and b is simply 2, the cube root of the second term. Okay, so let's go ahead and rewrite our formula again. A to the third plus b to the third. So do you remember the mnemonic device? So we're going to have A, the first sign is the same, plus B, A square. The next sign is opposite, AB. And then the last sign is always positive, plus B square. Okay? Now, let's apply to this problem. So in this problem, we have x to the third plus, instead of 8, we can write 2 to the third. 2 to the third and 8 are the same things, okay? So let's expand that. We'll have x plus 2 times x squared minus 2x plus 2 squared, which is 4. So this is the factored form of x to the third plus 8. So which of these options here match this factored form? Clearly, it's not that. Let's see. Oh, option letter 3. Okay, so this one you say yes, and then the other two you say no, no. Okay, so one quick thing I just want to note, is that the exponent, the exponential value distributes only across product and quotients. Okay, the exponent does not distribute across sums or differences. Okay, so what does that mean? If you have a over b to the third, guess what? This exponent can be distributed to the top and bottom. So you have a to the third divided by b to the third. This is legal. All right? Now, what if you have a product, a power of a product, so ab to the third. This distributes also. This is a to the third, b to the third. This is good. Now, if you have the sum or the difference of terms, you may not distribute the exponents. Okay, so let's try difference first. A minus b. A minus b to the third. Is this the same thing as a to the third minus b to the third? The answer is absolutely not. Okay? How about a plus b to the third? Is that the same thing as a to the third plus b to the third? The answer is no. Okay, so you want to watch out for these two common mistakes. That is what option 1 was indicating. Okay, that's a trap. You cannot factor out the exponent from this. Okay, if you have a minus b to the third, this simply means you are multiplying a minus b times itself 3 times. 3 copies of a minus b. Okay, and then if you have plus, is the same thing, a plus b 3 times. All right, so please do not distribute an exponent over sum or difference. Only multiplication and quotient. All right, let's move on to problem number 4. Okay, so for question 4, it says, click on two numbers whose product is irrational. Okay, so what are irrational numbers? Irrational numbers are numbers that cannot be expressed as a quotient of two integers. Okay, so just to keep long story short, if a number has an irreducible radical, it's irrational as an irrational number. Okay, other irrational numbers are e and pi are irrational too because they cannot be represented with a quotient of two integers. Okay, pi also is an irrational number. Now, let's see. The question states that which two are going to be irrational when you find their products. Okay, so this is something you want to know. Let's go over some real quick rules here. So the first rule is as follows. If you multiply two rationals, guess what? A rational multiplied by a rational will always give you irrational. Okay? Rational times rational gives you irrational. Now, How about if you multiply a rational and an irrational number? What do you get? Irrational times an irrational is always going to give you an irrational number. Okay? And then how about irrational times irrational? Irrational times irrational. Well, this one is a little bit ambiguous. It depends. In this case, irrational times irrational, you can get either irrational or irrational. Okay, so you're not guaranteed to get one or the other. If the radicands are identical, then you get a rational. The radicals, of course, have to be in reduced form. But if the radicals in reduced form are not identical, then when you multiply the two irrationals, you end up with an irrational number. Okay? So this is much easier to understand when you're working with concrete numbers. In this case, you ask for two numbers whose product is irrational. So what are two numbers here that when I multiply them, I do not have a radical component in my final result? So first thing you want to ask yourself is, are all the numbers reduced? These first three numbers are reduced. What are they? These are rational numbers. This number is reduced completely, so it's irrational because of the radical piece. Now, how about root 8? What kind of number is this? Well, if you take a look at this number, it appears as though we can break it further. So let's break it down. Take out 2, 2 times 4, 2 times 2. Oh, these two 2's repeat, so the square root of 2 times 2, which is 4, the square root of 4 is 2. So root 8 can be written as 2 root 2. Now, what kind of number is this? This is an irrational number because of the radical 2 there. Okay? So now, if we select any 2, we want to make sure that we do not have any radicals. Okay? What if I select 3 root 2 times root 8? What is my answer going to be? Am I guaranteed to have an irrational result? Well, let's work it out. 3 root 2. We just found out that root 8 is the same thing as 2 root 2. If you multiply them together, 3 times 2 is 6. Root 2 times root 2 is root 4. We have to reduce completely. 6 times root 2. Root 4 is 2. 6 times 2 is 12. What kind of number is this? It doesn't have any radicals. It is rational. So the selection of these two options right here, that's wrong. Okay? So in order to play it safe, we can just pick a rational and an irrational, because anytime you multiply a rational and an irrational, you always get an irrational product. So we can pick any of these first three numbers and any of these two. Okay, so I can pick -5 and 3 root 2 or root 8, that will work. Or I can pick or I can pick this like that. I can pick 1/3 and any of these two. I can pick 2/3 and any of these two. Okay, so let's just pick the first rational that we have and the first irrational that we have. Okay, now we find the product of those two. -5 times 3 root 2. What will our result be? This will be -15 root 2. Is this rational or irrational? Because of this radical piece right here, this is irrational. That's exactly what we want. Okay? Now, one thing you want to note before we move on is that in a problem like this, on the sbac test, there are multiple different answers for this problem. Okay, you do not have one unique answer, so there are multiple answers here. So just keep that in mind, because questions like this show up over and over again. Okay, so let's take a look at the last question for this part. You definitely want to subscribe to our channel so that you can get updates to the remaining of the tutorials on this review series. Okay, so for problem number 5, we are to solve the equation 18n squared minus 50 equals 0. All right, it states that we have to enter one solution in the first box. If there are two solutions, enter the second solution in the second box. So we have to be really careful to ensure that we enter all our answers in the spaces provided. Okay, so to solve this, we're basically trying to isolate n. First thing we do, we add 50 to both sides. We have 18n squared equals 50. And then we're going to divide both sides by 18. We have n squared. Now, we can reduce these two by a common factor of 2. So divide top and bottom by 2. So we have 25 over 9. Now, to get rid of this square, we'll simply root the left side and then root the numerator and the denominator. You never want to have a fraction as a radical. Okay, that's not a reduced form. So we have n squared, n, let's write that again. N equals, anytime you take the square root of a square, you have to introduce plus or minus. So plus or minus, the square root of 25 is 5 over 3. All right, so our answers are negative 5 over 3 and 5 over 3. So you notice there are two answers to this question. So you want to make sure you enter both of them here. Okay, so the first one is negative 5 over 3. And then, well, let's not enter it in that format. We can do negative 5 over 3. And the second answer is a fraction also, 5. And then click in the denominator, 3. All right, so there goes your two answers separated in both boxes. Thanks so much for taking the time to watch this presentation. We really appreciate it. Feel free to subscribe to our channel for updates to other great tutorials to get you ready for your Common Core examination. If you have any questions about this lesson or you would like to request any math tutorials, feel free to include it in the comments section below this video. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day.